Hello everyone, welcome to our sessions. In this series of videos, we are going to cover 9 chapters of Pure Mathematics 1. Chapter 3 is Equations and Inequalities. In this video, we are going to cover topic 3.7 Regions. We will going through each topic step by step. We'll do some exercise questions from book and we'll solve some past paper questions. End of the lesson, we will discuss some exam success tips. Let's start our journey. Topic 3.7 is regions. We have to identify regions that satisfy linear and quadratic inequalities. So we will look for both type of inequalities and we have to check our inequalities, and according to that we have to shade this region. For example, here this is a quadratic inequality graph, this is a quadratic graph. So suppose your inequality is y less than fx, then we have to shade the below part of the graph, as you can see here, y less than fx, which is outside the graph. And if your inequality is y greater than f of x, then we have to shade inside the part of the curve, and that will satisfy inequality y greater than f of x. We'll do some exercise question that can help you more. Exercise 3G, question number 2. On the coordinate grid, shade the region that satisfy the inequalities. We have 4 inequalities here. So we can do each inequality one by one. First we will find the coordinates so we can put onto graph paper. So this x greater than equal to -1 and y greater than equal to -2. We don't need coordinate because it's just a simple line is there. For this x plus y less than 4. So to find the coordinate, first we have to write equal to 4. When I take x is equal to 0, y is equal to 4. So my coordinate is 0, 4. When I will take y is equal to 0, my x is equal to 4. So this coordinate is a 4, 0. So these two coordinate we are getting for this line. Now another line we have is 2x plus y equal to 5. Y is equal to 5 minus 2x. When I will put x is equal to 0, my y is equal to 5. So that will give me 0, 5 point. And my y is equal to 0, that give me x is equal to 5 over 2. You can simplify it. So 5 over 2, 0. So these coordinates we are getting it. Now one by one we will try to plot the lines. First line is x is equal to minus 1. So this is my line, x is equal to -1. And we are putting this line as a solid line because there is an equal to sign is there. Sorry guys, I have to do it again. So this is the line x is equal to -1. It's not straight. The second is y is equal to -2 graph. So for that, because it's a equal to sign is not there, we have to use the shaded line. So I'm using this line. It's not clear. Let me use this one. This line is there. The third line, which is x plus y greater than 4, 0, 4. So 0, 4 is this coordinate, 4, 0 is this coordinate. So our line pass through like this. And the third line, which is 2x plus y is equal to 5, we have a 0, 5. So x is 0, y is equal to 5. So again I am using the red one, so that will give you this one point. And 5 by 2, 0. So that is 2.5 will give you this. So this line is there. Now we got all the lines. Now we have to find, or we have to shade the region for this. So first x greater than equal to -1. So as you can see, this side of the line will give me the greater than inequalities. So I can shade this type of graph. So I am just putting a simple line that can help us this side. Y greater than -2. That means the upper part of this line, which is this y is equal to -2 line. So I am using this upper part. X plus y less than 4. So now this is the line, that line we are telling as a x plus y less than 4, and less than side, that means this side of the part that we are shading it. And the fourth one is 2x plus y less than is equal to 5. Now this is also, this line is there. So we are shading less than means the inner part. So as you can see here, if I put a triangle, this is the shape that we are getting as the shaded region. I will show you the how exactly it look like. So as you can see here, this shaded part exactly what we want it. So in exam, use pencil and shade the part, so that can help you. Let's move to next question. On the coordinate grid, shade the region that satisfy inequalities. We have 3 inequalities here. First is a quadratic, these two are linear. First, to draw, we have to find the coordinate. So we are writing y is equal to x minus 3 squared. We have to write equal to sign so we can solve it. To solve this, if I put y is equal to 0, then I can write x minus 3 squared is equal to 0. So x minus 3 equal to 0, x is equal to 3. So that will give us coordinate 3 and 0. If I put x is equal to 0 in this, we will get it y is equal to minus 3 squared, that will give us 9. So we will get 0, 9 as a coordinate. So this is the coordinate for the quadratic one, right? Now another one, x plus y is equal to 5. Put x is equal to 0, y is equal to 5. So the coordinate is we are getting 0, 5. When you put y is equal to 0, x is equal to 5, which is 5, 0. Now for the third line, y is equal to x minus 1. When you put y is equal to 0, you are getting x is equal to 1. So our coordinate is 1, 0. And when you put x is equal to 0, then y is equal to minus 1. So we are getting 0, minus 1. So now we have all the coordinate. Let's start drawing it. First we are drawing the quadratic. We know the quadratic graph shape is this because it's a positive axis there. But this graph is intersecting x-axis only at one point. So this is our point where it is intersecting. And the y-axis 9. We don't have 9 here, but we can assume somewhere here. So the graph is look like this. This is our graph for the quadratic equation. Now, to draw this line, 0, 5, this is this point, and 5, 0 is this point. So we can draw the line, which this line is there. And then we can use this line y is equal to x minus 1, 0 minus 1, this is the point 0 minus 1, and that is point 1, 0. So you can draw passing like this, right? Now, we have to shade a region. Y is greater than x minus 3 squared. Means greater than means we have to draw inside part of the curve. So we can say the inside part is there. I am not shading it now, otherwise it will look chaos. Another is y plus x greater than equal to 5. So now this is our line, which is this line, which is x plus y is equal to 5. And they are telling greater than. So greater than means this side of the region we are expecting. Okay. And for this line, which is y is equal to x minus 1 line is there, we are expecting less than. So that means this side that giving us the inequality which is less than. So now as you can see here, this part which is inside, which is our required region, because it's satisfying all three inequalities. It look like this, if you can see exactly this way. So this is our required region. Let's move to next question. Let's move to question number 6. The sketch shows the graph of the straight line with equation. So we have a 3 lines here, 3 straight line. Work out the coordinate of the point of the intersection of the functions. So as we can see, we have a 3 intersection point. This point is for this line, which is y is equal to x plus 1 and y is equal to 7 minus x. This intersection point is y is equal to 7 minus x and x is equal to 1. And this intersection point, y is equal to x plus 1 and x is equal to 1. So we have to find 3 pair of coordinates for 3 intersection point. Okay. So we will do first part A. So as you can see here, to find this intersection point, we have to equate this two line. So we can write x plus 1 is equal to 7 minus x. That will give us this intersection point. Simplify it. So you can do plus x both side. So 2x plus 1 equal to 7, minus 1. So 2x is equal to 6. Divide by 2, x is equal to 3. So that will give us x coordinate. Now we have to find the y coordinate. So you can put any of the line equation. So here I can use y is equal to 3 plus 1, that will give me 4. So my first pair of coordinate is 3 and 4. Okay, that is this intersection point. I can write it down here, 3, 4. Okay, as you can see in the graph also we can get it, but we have to do this by calculation. Now second, this is line 7 minus x and x is equal to 1. So in this line equation, I will substitute x is equal to 1. So 7 minus 1, so y is equal to 6. So I get coordinate x is equal to 1, y equal to 6. This is this point we find it out, which is 1 and 6. To find the third intersection point, y is equal to x plus 1 line. In that I will again substitute x is equal to 1. So that will give me y is equal to 2. So our coordinate for this is 1, 2. So this coordinate, that is 1, 2. So we found all 3 intersection point coordinate here. Okay, part B, we have to find the 3 inequalities, because 3 line equation we have that satisfy this shaded region, which is R is there. Okay, we'll check one by one. First we am taking x is equal to 1. As you can see, this side of the line which is shaded in a R region is there, means it's the greater than value is there. So I can write x greater than 1, y equal to, because solid line is there. The another equality we are using is y is equal to x plus 1. Now as you can see, this side part will give us the greater than inequality, because it's R is on that side. So we can write y greater than equal to x plus 1. And the third line, y is equal to 7 minus x. So as you can see here, this is the lower part of the line, or the smaller part of the line we are considering. So y less than 7 minus x. So these are 3 required inequalities that satisfy this region R. Question number 7. Sketch the graph of the curves with equation. So we have 3 inequalities. This is quadratic and these 2 are linear. And you can see in the graph also we have these 3 inequality. Here we have to just write set of inequality that represent the shaded region. So we don't have to find the intersection point, just we have to write the inequality sign. So first we are checking for the quadratic equation. So as you can see, this type of the graph is there because it's a x squared is negative. So this below part which give you less than inequality. So we can write y less than equal to 2 minus 5x minus x squared. If this type of the graph is there, then that will give you the greater than inequality, which is inside part. But for this type of the graph, inside part will give you less than inequality. Another equation we have 2x plus y is equal to 0. So the red line, that is 2x plus y is equal to 0. Now as you can see, we are moving to the positive side. So you can see this value, we are moving to positive side. That means the shaded region is on the positive side. So we can write 2x plus y greater than equal to 0. This is also a solid line is there. Third inequality is which is blue line, which is x plus y is equal to 4. Now as you can see, this is below the line we are getting the R region, as you can see. That means this is give us the less than inequality. So x plus y less than equal to 4. So this is our required inequality, which is first, second and the third. That will satisfy the shaded region R. Let's move to question number 8. On a coordinate grid, shade the region that satisfy the inequalities. We have 4 inequalities here. For that, first we have to find the coordinates so we can sketch on the grid. For that, first take y equal to x plus 4. So when you substitute x is equal to 0, y is equal to 4. So the first coordinate 0, 4. If you substitute y equal to 0, then you are getting x is equal to minus 4, which will give us minus 4, 0. Okay. Let's first sketch this line. So the first point is minus 4, 0 and this is 0, 4. But there is no equal to sign is there. So we have to draw this line as a dotted line. So I can label this line y equal to x plus 4. Okay. For another line, y plus 5x plus 3 equal to 0, y equal to minus 5x minus 3. When you substitute y is equal to 0, 5x equal to minus 3, so x is minus 3 over 5. So the coordinate what we are getting is minus 3 over 5, 0. When you substitute x is equal to 0, y equal to minus 3. So the coordinate is 0 minus 3. Let's sketch this line. Minus 3 over 5 is kind of 0.6. So we are getting somewhere here. And this is the minus 0 minus 3. So that we are getting something somewhere here. Because there is an equal to sign is there. So we can draw this line as a solid line. So this line is, we can say y equal to minus 5x minus 3. Third line, y greater than equal to minus 1. So basically we have to draw the y equal to minus 1 line and it's equal to sign, so we have to draw the solid line. And the fourth line, x less than 2, x is equal to 2 and this is no equal to sign is there, so we have to draw dotted line here. So this is x is equal to 2 line and this one we can say y equal to minus 1 line. So the first part A is done. We sketch all this and then we have to shade the region. Now for that, y less than x plus 4. So for this line, less than region means we are substitute these regions are there, right? Okay. Y plus 5x plus 3 greater than 1. Greater than 1 means we are shading this side of the line. Okay. Y greater than equal to minus 1. So this is the side that we are getting, y greater than equal to minus 1, and the third one is x less than 2. So for that, x less than 2, this is line, so this side is there. Then you have to figure it out which part satisfy all the inequalities. So if you can see, now I am erasing everything and I am shading the region that what we need it exactly. So for that, actually I can use this red color. So for that, only this region which satisfy our inequality. I will show you exactly how it look like. So this is how the shaded region is look like. Now move to part B. Work out the coordinate of the vertices of the shaded region. So the shaded region is a quadrilateral. So we have to find 4 vertices for this shape. So we can label this is vertices A, this is B, this is C, and this is D. Now how to find the vertices? So first check the intersection point and which 2 lines are intersecting, and we have to equate these 2 lines. For example, for A, we have a line y equal to x plus 4 and another line is y plus 5x plus 3 equal to 0. So for that, first we have to equate x plus 4 is equal to minus 5x minus 3. So we can say 6x equal to minus 7. So x is equal to minus 7 over 6. Just we have to simplify. So this is the x coordinate. Now to find the y coordinate, use this equation x plus 4. So y equal to minus 7 over 6 plus 4. That will give you 17 over 6. So the coordinate of A, what we are getting is minus 7 over 6 and 17 over 6. This is the coordinate of A. Now go for the coordinate of B. Now as you can see in the B, which 2 lines are intersecting? So y is equal to minus 5x minus 3 and y equal to minus 1. So minus 5x minus 3 equal to minus 1. So minus 5x is equal to, if you move the minus 3 this side, so that will give you 2 because plus 3 minus 1. So x is equal to 2 over minus 5. So, and already we know the y coordinate. So this coordinate of B we are getting is minus 2 over 5 and minus 1. Now find the coordinate of C. So to find the coordinate of C, what we have to do is x is equal to 2, y is equal to minus 1, which is easy. So we will get the coordinate 2 minus 1, right? And then to find the coordinate of D, we have a 2 lines, x is equal to 2 and y is equal to x plus 4. So substitute in this equation y equal to 2 plus 4 will give me 6. So the coordinate of D what we are getting is 2 and 6. So these are the 4 coordinate. Let me do this is coordinate of A, this is coordinate of B, this is coordinate of C, and this is the coordinate of D what we are getting it. So this is coordinate D, C and B. So this way we can find 4 coordinate of the vertices. Let's move to point C, where which of the vertices lie within the region identify the inequalities. For that we have to find which point is having 2 solid lines. So you can see point B is having a 2 solid lines. So point B, which when minus 2 over 5 and minus 1 is the vertices that I am looking that included in the region. Now move to question D. Work out the area of a shaded region. Now to find the area of the shaded region, as you can see in the graph, this is point B here. To find this yellow part, I can take a right angle triangle, which is the big one, and I can take away this small triangle from that. That will give me the area of the shaded region. Now to find the area of a right angle triangle I am writing, I can use the formula half times base times height. Now my height, as you can see, from -6 to -1. So it can give me 7, and my base is -5 to 2. That also giving me 7. That will give me 49/2. That's the area of the big right angle triangle, as you can see here. Now, area of unshaded triangle, which is the smaller one. To find this, to find the base, I can use the coordinate. So I can use -2/5 -5 times. To find the height, I can use 17/6 -1. So when you simplify, it will give you 529/60. So this will give me the area of a small triangle. So to find the area of a shaded region, so area of shaded region, we can do the big triangle, which is 49/2, minus the smaller triangle 529/60. That will give me 941/60. So this is the area of a shaded region. Let's move to past paper questions. Figure 5 shows a sketch of a curve equation 4x squared plus 9y squared plus 4xy is equal to 64. The curve crosses the negative y-axis at the point P, as you can see here in diagram, and the line L1 has the gradient to end passing through P as shown in figure. A part, find the equation of a L1 giving your answer in form of y is equal to mx plus c. So as we know, to find this equation, we need two values m and c. C means a y-intercept. So to find the y-intercept, we know this line crosses the y-axis at point P. Crosses y-axis means x is equal to 0. So first substitute value here, x is equal to 0. So 4 squared plus 9y squared plus 4 into 0 into y is equal to 64. So this term is 0, this term is 0. So we can say 9y squared is equal to 64. So we'll do the square root both sides. So 3y is equal to 8. So y is equal to 8/3, right? So this is our y-intercept. Now, we know the gradient is 2. So we can make now equation y is equal to 2x minus 8/3, because they are telling negative y-axis. So we can say is y is equal to 2x/c. So this is part A answer, because we have to find the y is equal to mx plus c, and this is our equation, right? Let's move to part B. We have another line, which is line L2. It has the equation y is equal to 2x plus k. Show that the y-coordinate of any points where L2 meet our curve C are solution of the equation this. So basically we have to rewrite our curve equation by substituting this value of y in this form. Now to substitute value of y, we have a 2x plus k. So y minus k is equal to 2x, and y minus k over 2 is equal to x. So this is our value of x that we are substituting in our curve equation. So as you can see, our curve equation is this: 4x squared plus 9y squared plus 4xy is equal to 64. So here we are substituting in our curved equation, so which is 4x squared plus 9y squared plus 4xy is equal to 64. Substitute value y minus k over 2 squared plus 9y squared plus 4y and substituting value y minus k over 2, which equal to 64. So simplify 4y minus k squared over 4. 2 squared is equal to 4 plus 9y squared plus 4y squared. Okay, before doing this one, what we can do is we can divide 4 with 2. So that will left only 2y, y minus k is equal to 64. That make our simplification easy. Here also 4 and 4 get cancelled. So y minus k squared. So y squared minus 2ky plus k squared plus 9y squared. This one is 2y squared minus 2yk is equal to 64. Now simplify it. 9y squared, 2y squared, y squared. It will give us total 12y squared. Minus 2ky minus 2yk, which is minus 4ky plus k squared, and I am moving 64 this side, minus 64 is equal to 0. So this is our required equations. Given that this line L2 meets C at a 2 distinct point, find the range of possible value of k, which is part C. Now we have this equation, right? We already know we have a 2 distinct point. That means our b squared minus 4ac greater than 0. So for that we have to find the value of a, b and c. So as you can see here, our a is equal to 12, b is equal to minus 4k, and c is equal to k squared minus 64. Substitute value. So b squared we can write minus 4k squared minus 4a, c is k squared minus 64 greater than 0. So minus 4 squared is 16k squared minus 12 times 4, which is 48, multiplied by k squared. So 48k squared plus 48 times 64 will give you 3072 greater than 0. Now we are writing, okay, first simplify this: 16k squared minus 48 squared, that will give us minus 32k squared plus 3072 equal to 0, because I have to find the value of k, so I have to write equal to 0. I am moving minus terms on the other side, so 32k squared is equal to 3072. So k squared is equal to, when you divide by 32 both side, we have a 96. So k is equal to plus or minus 4 root 6. Now this is our two value of k is there. Now we have to write a range. So minus 4 root 6 less than k less than plus 4 root over 6. So this is our range for value of k. Let's move to question number 2. As you can see in this figure, we have three things. First, line L1 with equation 2y is equal to x. So this is our line L1. Curve C with equation this. So we know the equation of curve as well. And the region R shows the unshaded figure 1 bounded by the line L1, the curve C and line L2. So we don't know the equation of line L2. Given that L2 is parallel to the y-axis and passes through the intercept of C with the positive x-axis, identify the inequalities of R. So we know equation of line L1, we know the equation of C. We have to figure it out, equations for L2 line, and then we can write the inequality. To find this one, we have to find the common point for the curve C and line L2. So for that, I can write y is equal to 2x minus 1 over 8x squared. Now is intersecting x-axis, so we can know the y coordinate is 0. So 0 is equal to 2x minus 1 over 8x squared, right? Simplify it. So 0 is equal to 16x minus x squared. Take x common, so we will get 16 minus x. So we will get a true value of x is equal to 0, and 16 minus x is equal to 0, so x is equal to 16. So that means this is our 0 point and this one is a 16. So that means this line L2 is x is equal to 16 line is there. So now we have all the equations. Now how to write the inequalities? So as you can see, this shaded region R, which is the outside region of the curve. Now outside region of the curve means we have to write inequality y is greater than equal to 2x minus 1 over 8, because it's the graph, so the upper part means that will give us the greater value. And why I'm putting equal to sign? Because it's the solid line is there. What about the another L? So as you can see, this is the below L part is there. As you can see, this is the below part. So for that I can write 2y less than equal to x. So this is another equality because it's a below line, that means less than inequality is there. In the third line equation, x is equal to 16. So as you can see, this is the lower side of the x is equal to 16. So I can write x less than 16. Now I am not putting equal to sign because as you can see, line L2 is a dotted line is there. So region R is represented by these three inequalities. Move to question number 3. As you can see in this figure, we have a curve with equation x squared minus 5x plus 3. It has a minimum point of C, means the minimum point M of the curve C. The straight line L passes through the origin and intersecting C at the point M and N as shown. Find, showing you are working out the coordinate of M. So last topic we did it. If you want to find the coordinate of the turning point, then we have to, for this equation, we have to do completing squared. So that will give us the coordinate for the turning point. So how we can do complete square of this one? So this is your B. So x minus 5 over 2 squared minus 5 over 2 squared plus 13. So x minus 5 over 2 squared minus 25 over 4 plus 13. When you simplify, you can write x minus 5 over 2 squared plus 27 over 4. You can put this in a calculator, that will give you answer. So this is our one coordinate, which is P, and this is our Q. But we need this with the opposite sign. So the coordinate for M is equal to 2.5, or you can say 5 over 2, and 27 over 4 will give you 6.75. You can also write 5 over 2 and 27 over 4. It's the same thing is there. Okay. So any of the answer is okay. So by completing square, we will find the value of coordinate of. Now part B, find the coordinate of n. So as you can see in here in this line, to find the coordinate of n, we can equate equation of line L and the curve equation. So that will give us two coordinate, but we don't know the equation of line L. So first we have to figure it out, equation of line L. So how we can do it? So for that we need a gradient first. So we have a two coordinate 2.5 and 6.25 and 0, 0 because it is passing from the origin. So our gradient is equal to y2 minus y1 over x2 minus x1. So that will give us 6.75, sorry, it's a 6.75 is there, minus 0 over 2.5 minus 0, and 6.75 over 2.5, when you divide it, you get 27 over 10. We can write 2.7. So our gradient is 2.7, and we know it's passing from 0, 0, so y coordinate is 0. So our line equation is y is equal to 27 over 10x, or you can write y is equal to 2.7x, right? So now we have to equate this our line equation with the curve equation. So 2.7x is equal to x squared minus 5x plus 13. So this is our curve equation, right? So now we have to simplify this one. So x squared minus 5x minus 2.7x plus 13 equal to 0. So x squared minus 7.7x plus 13 equal to 0. So as we know, there is a decimal is there. So the best way to do is quadratic formula. So my a is equal to 1, b is equal to minus 7.7 and c is equal to 13. Put into quadratic formula, x is equal to minus 7.7 plus or minus 7.7 squared minus 4 a, c is 13 over 2a. Okay. So you will get, when you put in a calculator, two value, which is 5.2 and x is equal to 2.5. Now as you can see here, already the point for point n we find 2.5. So that means for the n the coordinate must be 2.5. Sorry, 5.2. So that means I have to substitute this coordinate into equation of y. So I can write it down, y is equal to 2.7 into 5.2, because y is equal to 2.7x is there. This is our equation. So I substitute it. So that will give me 14.04. So my coordinate for n is equal to, or n you can write like this, 5.2, 14.04. So we have a two coordinate, but this coordinate already we find for a m. So we have to use this coordinate for n. Okay. Now part C for the same question. So as you can see in a figure 3, the curve C, line L, and the region R, which is the shaded region, is there, and y-axis, C, L and the y-axis. So we have to look for the y-axis as well. Use inequalities to define the region R. So we can see here, first, this is the below part of our curve. So we can write it down, y less than x squared minus 5x plus 13. And as you can see here, I will erase this so you can see clearly, there is a dotted line is there. That means we don't have to put the equal to sign. Then for this line, line L, we can say y is greater than 2.7x, because the greater value of y is there because it's the upper part of the L line. And for this y-axis, we have to write this region here. So we can write this 0 less than equal to x less than 2.5, because we know the coordinate of m is 2.5. So this region we are using it, and this is from starting from 0. So 0 less than x less than 2.5. So these three inequalities will satisfy the shaded region R. Let's move to question number 4. Solve 3 over x greater than 4. So to simplify this, we have to remember for this type of the questions, both sides I have to multiply with a x squared. So that will give us two solutions. Here one x is cancelled, so 3x is greater than 4x squared. Okay. So I'm taking this side. So 4x squared minus 3x is equal to 0. X is common, 4x minus 3 equal to 0. So we are getting two value, x is equal to 0 and 4x minus 3 equal to 0. So x is equal to 3 over 4. So this is two solution for this value. Remember, this is very important. When there is a denominator x is there, both side we have to multiply with x squared. Okay, now move to the B part of this question. So as you can see here, figure 1 having a sketch of the curve C and the straight line L. We have this region R here. We know three things here. L has a gradient 3, the curve equation, and C and L intersect on the negative axis. So here, now use inequalities and define the region R. So to define this region, we need equation of line L. So we know gradient, but we don't know the y-intercept. So what we can do is, first, we can find two intersection point of this curve with an x-axis. So I can do 2x squared minus 50 is equal to 0. 2 into x squared minus 25 equal to 0. So 2 into x plus 5 x minus. Do you remember the difference of 2 squared? So we will use here. So we will get x is equal to minus 5 and x is equal to 5. But we know we have to use the negative coordinate. So this coordinate is minus 5, this coordinate is 5. So for this, we have to do now to find the equation of line. Do you remember the equation of line? Y minus y1 is equal to m into x minus x1. So our y value minus 0, our gradient is 3, and x minus 5 we are writing it, because we have to use the negative value. So y is equal to 3x minus minus plus 15. So this is our equation of line L. Now we can write the inequality. So as you can see here, this part is outside the curve. So we can write it down, but in the negative side. So we can write y less than 2x squared minus 50. We can write equal to sign as well, because there is a solid line is there. The another for the y line, we can say is the upper part. So is the greater value is there. So y greater than equal to 3x plus 15. And another line which is y is equal to minus 5 line. So you can imagine this line here which is less than. So you can write x less than minus 5 line. So that will give us three inequalities which satisfy region R. Important takeaway for this lesson: if y is greater than fx or less than fx, then curve is not included in the region because there is no equal to sign is there. And when you represent that curve or a line, we have to use the dotted line. But if y is greater than equal to 4, if the equal to sign is given, then we have to use the solid line, and these points are included in the region. For required region, the shaded required region, select one point and substitute any of the inequality. If it is satisfy the inequality, that means that is your required region is there. Just to double check, you can use this one. A vertex is including only if both intersecting lines are solid lines. So in one of the questions, they are asking you to find the vertex of given shape. It is included in region or not. So you have to look for two solid lines. Thank you for watching this video. If you find this video helpful, please give it thumbs up. Do subscribe for more math content and let me know in the comments if you have any questions or topics that you would like to see next.